This video is going to cover the prerequisite skills associated with radical expressions and the laws of exponents. You are strongly encouraged to pause this video now and copy the diagram at the top as well as the examples that follow. Throughout this video, you are also encouraged to pause and attempt the practice problems before the explanation begins. Alright, so let's go ahead and get started. I'm going to assume you have already copied this diagram at the top, so let's just talk about it for a moment and then we'll do a few of these problems. So what you're going to notice is in radical form, we have the power, which is the exponent on whatever is under the radical, in this case, the letter A, and then the root, which is in the position of the little radical sign, and that letter N could stand for any number. Now, what you've typically seen is just the square root symbol, which by definition has a 2 as its root, but you never need to see the 2 printed there. You just have to know that a 2 is the root when there is nothing printed in the root position. But in this upcoming unit, we're going to be talking about situations where the numbers 3 or 4 or 5 could be in the root position, and you have to be able to handle the simplifying procedures that come with that. Now, a big part of being able to do these problems is rewriting something from radical form into exponential form. And that's what this main slide is going to be focusing on, just that basic procedure. Now, what you're going to notice is that when you rewrite from radical form into exponential form, the power, which was originally the exponent on the variable a in that case, is going to go in the numerator of the fraction exponent, and the root is going to go in the denominator. So basically, you're going to be making exponents that are fractions now. You can have a to the second power. That's something very common because it's a whole number exponent. But what we're going to be getting in this lesson are exponents that could be fractions. And the way you rewrite these fractions is you get the positions of m and n from the radical form original setup that's over here on the left. So enough talking about it. Let's just go ahead and get into doing a few of these. Number 1, convert x to the power of 7 over 4 into radical form. So 7 is in the position of the power. It's in the numerator. Look at that diagram and notice m is in the numerator. It is the power, and in this particular example, 7 is the power that we are working with. 4 is in the denominator. That's the root. And because 4 is in the denominator, we know that 4 is going to become the root. So we have the fourth root, and then the power that goes on x is the number 7. So the way you say this answer is the fourth root of x to the 7th power. That's one way of saying it. Now take a look at number 2. It's the same idea, only now we're going to be converting into exponential form. So we're going to be going back from exponential form into radical form. And it's the same procedure. Power over root is how the fraction is set up, but the root is always going to go in the position where the radical sign is located, and then the power is just going to become the exponent. So we have 5 being the power, 11 being the root, so x to the power of, and think about this for a moment, what's going to go in the numerator? Which number? Is it 5 or 11? And that would be the number 5 because 5 is again the power, and that means 11 would go in the denominator. Now, problems 1 and 2 are taking you through the procedures of rewriting, and that is a very baseline core skill for the upcoming unit. What you're going to have to also incorporate are the laws of exponents that come from Algebra 1. So problem 3 is going to help us review one of those critical laws of exponents, and that is the multiplication law, and it's the one where if you're multiplying two bases that are the same, so if you take a look at number 3, we're multiplying x and x, and if you multiply the same bases, then that really means you're going to take the exponents and add them together. So a more rudimentary example of this would be if you saw x squared being multiplied by x to the 7th power. You would just add 2 and 7 and you would get 9. So x to the 9th would be that answer. And that was done very easily because you're just adding 2 and 7 and you don't have fractions to worry about. But in this upcoming unit, your exponents are going to be fractions. fractions. So that means you're going to have to add fractions together. Here is a quick rundown of what that's going to look like. We are adding 2/3 and 1/5 together. Oh, I see I just made a little edit there with it being 1/15. Okay, there we go. Let me just fix that. All right, so 2/3 plus 1/5, we are going to have to get a common denominator of 15. So we can multiply 2/3 by 5 and 5, and that's going to make the numerator become 10, and then 3 times 5 is 15. And the other fraction, 1/5, to make that have the denominator of 15, we're going to have to multiply by 3. Oops, and I can just see that the animation didn't show up there, so let's just fix that. We would have to multiply by 3, and then that's going to make the 3 times 1 become 3, and a 15. Oh, and I can see there's a few more edits I gotta make right here. 10 plus 3, that's going to give us 13. Let me just fix that piece. And now we're back on track, and I bet the other writing that I pre-wrote is now going to be wrong, but whatever, we'll just roll with it. So we now have the fractions added, and we have 13/15. 13 is in the numerator, representing the power. 15 is in the denominator, representing the root. So we have, and there's the other error, let me just fix that. So it's going to say 13/15. We just added those two fractions. We got 13/15 as the new power of x, but just notice it is asking for things to be in radical form. So we're going to have to go back to that diagram at the top where we know the numerator is the power and the denominator is the root. That's something you should say to yourself a few times. Power over root, power over root. And now when we rewrite it, 13 is going to be the power. Oops, and there's that 11 coming in again for the last time. Fixing that. It's now a 13. All right, the 15th root of x to the 13th power. That's how you would say that answer. And once again, we had to do that extra work because we were multiplying those x's together. And because we were multiplying them, we have to add the exponents. But the exponents were fractions, so we had to go ahead and find common denominators. But the animation I had pre-written was a little wrong, so I had to kind of fix that on the spot. All right, number 4. Rewrite into exponential form, and you're going to notice that we have radicals right now. So here's a way to approach this problem. You might want to pause and just try it on your own first, but if you're going to just watch, then definitely set it up the way I'm about to show you. So the key thing to remember is that whatever the root is, whatever number that is going to live in the denominator. That is the only location you're going to move that number to if you're going to be rewriting from radical form into exponential form. You're going to be putting roots always in the denominator. Now, the reason why I'm telling you that, you will notice that we already have an expression that is that has an rational exponent of 5/2. So you might be asking yourself, well, how am I going to do power over root? How am I going to rewrite this if we already have an exponent that's a fraction? Because just to give you a similar example, if this said the cube root of x to the, 7th power, then we know 7 is the power going in the numerator and 3 is the root going in the denominator. Well, okay, that's a very easy example. But what do you do in the situation when you already have a rational exponent? It's actually very simple. Just remember, roots live in the denominator. That is the only place you should be moving it to. Since we already have a denominator of 2, just go ahead and put the root of 3 in the denominator with the 2, multiplying them together. And that's going to give you a 6 in the denominator, and there's nothing to do with the 5. So in exponential form, you would have x to the power of 5/6. And you basically did power over root. It's just that you already had a power that was a fraction. So just take the root, because it always goes in the denominator, and multiply the denominator you already had, which was the number 2, by 3. And 2 times 3 is what gives you 6. Let's go ahead and look at a few more of these on the next slide. Okay, this might be a good time to also pause the video and try to work these out on your own. I'm going to talk through these kind of quickly when I come back, and that will bring us to the end of the lesson. So go ahead and pause and give these a shot. And all right, we'll come back in with number 5. So we're simplifying the square root of 45. Now, this is something that has probably happened before in Algebra or Algebra 2 class. We're going to take 45 and ask ourselves what two numbers multiply to make 45, but one of those numbers needs to be a perfect square because we are finding the square root of 45. So we need to be thinking about the perfect squares that multiply to make 45. Just to give you a counter example, we would not want to use 15 times 3 in order to simplify this problem because neither 15 nor 3 are perfect squares. So we wouldn't be able to do any of the simplifying at that point. But the number 9 is, and I'm assuming you know what I'm talking about when I say perfect squares, so we will just continue. Since 9 is the perfect square, we can go ahead and square root it and get the number 3. And since 5 is the prime number, it just stays under the radical sign, and that is all we would have. Now, you might also be saying, well, if you're taking the square root, doesn't that mean the plus minus symbol has to be introduced? That is fine if you want to write it, but for the sake of this lesson, we can go ahead and stick with the principal square root, which just means the positive answer, just to save on the writing time and all the whatnot. But feel free to put the plus minus sign if you want. For the sake of the video, it's just going to be the principal square root that will be written down, which is just the positive answer. Okay, number 6. We're now taking the square root of y to the 7th power. Now, you might have thought, well, okay, let me just rewrite it to 7 over 2 because there is a 2 in that position, but that's not really simplifying. Here's what you're actually going to do, and this might be a little bit of a learning moment because this concept is going to appear throughout the entire unit, so please listen very carefully. When you are taking the square root of y to the 7th, I want you to first think about it as a bunch of y to the 2nd powers until you can't make any more of them, and then you just have the extra 1 that is left over. So if you just notice those exponents, we have 3 2's, and if you added them all together, you'd get 6 plus 1 is going to equal 7. All I did was take y to the 7th power and rewrite it as 3 copies of y squared with an extra copy of y to the 1st power right at the end. Now, the reason why I did that as pairs, that I thought about how many pairings of y's can I get under the radical? Well, that's because we were looking for the square root. So we wanted to take our variable and think about how many pairs can be created. If you take a quick look at number 7, we're going to be finding the cube root. So when we deal with those y's, we would want to be thinking about groupings of 3 when we are making those y's. But we'll get to that in a moment. Let's finish talking about number 6. Since we can make 3 groupings of y squared, we can go ahead and simplify all of them because you're taking the square root of y squared. So the square root of that first y squared is just y, and then the square root of the second y squared is again just y, and the third one is a third y. Now, what does that mean? Well, a y cubed is going to come out of the radical simplifying process, and that is the first thing that is written down in the answer, and then the remaining y to the 1st power stays under the radical sign because we were ultimately looking for the square root, and there was only a single y left over at the end, so you can't simplify that any further, and it just comes out as under the radical sign, and then we have our answer, y cubed, and then times the square root of y. Now, there's a little pattern you can kind of notice here, and that might help you work through this style of problem in general when we get to number 7. If you just notice that the exponent of the answer, that 3, if you multiply that by 2 and add 1, you're going to get that original exponent back. This is something that always happens when you have the variable with an odd exponent. Let's just say I'm going to put the number 21 up here. So the way you quickly figure it out is drop the exponent by 1, so 21 goes down to 20. I should put the square root sign there, my apologies. We will take the square root of y to the 21st power. So again, drop the 21 down by 1, so you have y to the 20th power that you're square rooting, but then 20 divided by 2 is going to be 10, so you have y to the 10th power, and that original exponent that you dropped when you went from 21 down to 20, you just stick that under the radical sign as the y all by itself. And that's just the pattern that you can use in that situation all the time. If that didn't quite make as much sense, just keep following along and you're going to see the example come up again and again and again. But that's the basic procedure for how to check that you've done this correctly or work through it quickly. But okay, let's go ahead and, I guess I had pre-programmed one answer to be looked at right there. Maybe do that one really quickly for the sake of practice. The square root of y to the 11th power. You can think of that as y to the 10th times y to the first power. And then when you square root that, y to the 10th becomes y to the 5th. And then the y to the first power stays under the radical sign, and there you have it. All right, very quickly, number 7, and then we can wrap things up. So in number 7, we are now finding the cube root of 24 times y to the 7th power. And when we find the cube root, we have to be thinking about our perfect cubes. We have perfect squares like 1, 4, 9, 16, 25, but we also have perfect cubes like 1, 8, 27, 64, 125. And I am more or less assuming you are basically familiar with perfect cubes at least. Just to quickly give you the main idea, 8 is a perfect cube because 2 times 2 times 2 equals 8, or 2 to the 3rd power is going to give you 8. Likewise with 27. 27 is 3 cubed because 3 times 3 times 3 is 27. And that is the same flow with 64 being 4 cubed and 125 being 5 cubed. So I'm assuming we have a basic familiarity with cubes and cube roots, and let's just go ahead and continue. So we are finding the cube root of 24 y to the 7th, and the first thing you would ask yourself is what perfect cube is going to multiply to make 24 with another number, and that would be 8 times 3. We don't want to use 12 times 2 because neither 12 nor 2 are perfect cubes, so those numbers would not get us to the answer. Same thing with 6 times 4. You might go, but 4 is going to work. That's a perfect square. Doesn't matter. We're not looking for perfect squares. We're looking for perfect cubes this time. So 8 times 3 is going to give us 24, and we will be taking the cube root of that. We will also be taking the cube root of y to the 7th, and this goes back to what I was saying before about making groupings of 3 y's at a time. And basically, y to the 7th could be split into y cubed, another y cubed, and then a y to the first power, because 3 plus 3 plus 1 is going to equal 7. So this is just how you can train your brain to think about what the end result's going to be. I showed you another way of doing it where you could also just think of this as y to the 6th power times y to the first power. And since 6 is divisible by 3, when you take the cube root of that, you're going to have a y squared coming out with that y 6th when you take its cube root. And then the y to the first power would stay under the radical sign. That is the other way of thinking about it. But let me just back that work up, and I would say if what was just shown in purple was a little too much for how you're thinking, just notice the patterns. When you're trying to find the cube root, you need to have groupings of 3 of that variable at a time. When you are trying to find the square root, like we did in number 6, you are going to be finding groupings of 2 of that variable at a time. And there'll be more examples coming up with that same idea in no time. But once again, 3 plus 3 plus 1, that's going to equal 7, and that's how you know you've made the correct number of groupings. You're always going to have a extra variable at the end. I guess maybe just for the sake of practice, we'll do this on the spot. Why not? Let's say you're finding the 4th root of y to the 26th power. Pause the video and test yourself for a moment. Y to the 26th power. All right, and here's how you do it. So the fast way, we'll just cut to the fast way right now, is you want to ask yourself, well, what is the closest number to 26 that is divisible by 4? And that's how many y's you would need to kind of separate from the 26. So hopefully your times tables are quick enough where you will know that 24 is the closest number, below 26, I should say, not above. Yes, 28 is divisible by 4, but we're going below 26. And below 26, the greatest number that is divisible by 4 would be 24. So when you take when you rewrite this, we would have the fourth root of y to the 24th power. And then, actually, let me just move that over a little bit. Y to the 24th power, and then the extra 2 y's that were left over to get to 26, you just write those down after it. And now we can take the fourth root of y to the 24th power, and that's going to be y to the 6th power. Just do 24 divided by 4. And then what's left over, which was the y squared, that stays under the fourth root sign. So the fourth root of y to the 26th power is going to give you y to the 6th power times the fourth root of y squared. I know that sounds weird and whatever, but that is the basic skill. And if you need to pause and rewind that, maybe do it again just to test yourself to see if you understand it. And again, more of those will pop up in due time. All right, back to finishing up number 7, little tangent right there. Let's go ahead and simplify. So the cube root of 8, that's going to be 2. So we get to take a 2 out of the radical setup. And then the pairings are the groupings of y cubes. There were 2 of them, so we got to cross out both of those. And notice, it's not a y cubed you write on the outside. It's a y squared because we crossed off 2 groupings of y cubed. That's a very big important thing to notice, that if you were kind of zoning out right there, you might want to pause and rewind just to make sure you got that point. We are not writing a y squared right here, or we're not supposed to write a y cubed because it said y cubed under the radical. That's a very common misconception. There were 2 groupings of y cubed that we crossed off. So y squared, 2 y's, came out of the radical sign to be in the front of the final answer. Everything else stays under the cube root sign. So the 3 and the y to the first power stay under the cube root sign. But very important to note that because we crossed off 2 groupings of y cubed, we have a y squared in the front of the problem. Well, all right, that does bring us to the end of the video, but what I will leave you with is what the next video's bell work is going to start with. It might not be a bad idea to pause right now, try these, and then I'll just flash the answers at the end, and the next video will explain them more. All right, thanks for listening, and I'll see you guys in the next video. And here are the answers. Oh, fast forward. There we go. You can see it right there. There's the answer to number 1, and there's the answer to number 2. All right, see you guys in the next video.